Yep, hopefully you can hear me just fine.
Yes.
And then hopefully if I click screen share, it's all good. Great. So yeah, I'm Lewis Alcott, and this is some work me and Ed have been doing over the last couple of years, really, but something that really kind of kicked off in terms of being something really official in the last year or two. And basically, it's using Pokemon as a way to teach, or just videos in general as a way to teach. And we're both trained as earth scientists or geologists. So we thought, you know what, it's probably a decent place to start. So we can look at how earth sciences are represented in other forms of media. So, for example, probably the most well-known one is Jurassic Park on the far right here with the T-Rex. And it kind of all comes from in 1993, when this film came out, there was a huge increase in the amount of people signing on to do geology-based subjects or paleontology-based subjects. There's a huge boom of engagement in paleontology with the release of Jurassic Park. And then some more not very scientific, not very brilliant scientific representations of Earth sciences of 2012 in the bottom left with these large natural disasters that are just shown to the public audience, which is great in terms of exposure. And then also a film that hopefully some of you recognize, Armageddon in the top left, where these oil drillers are just sent out to try and save the Earth by blowing up a meteorite. And the interesting thing is, when you look at Armageddon, you look at the variety of people that are really represented as earth scientists or geologists, and it's not very diverse. So what does a geologist do and what do they look like? So Rogers et al. Earlier this year came out with a preprint that basically came out and said that all we do is look at rocks and all we do is have beards. And great, it's not great when probably the most recognizable geologist in terms of present day is Bert from the Big Bang. It doesn't look great from an outsider perspective. With some of the big questions being, what did I trip over, as well as dumb as a bag of geologists. So it's kind of highlighting the fact that we're not engaging with an audience that is diverse. We're almost classist in a way. And this is something that we really need to change. So when we compare earth science to games or gamers in general, we can look at the percentage of female identifying people within faculties globally in earth sciences as well as related subjects. And we see it's not great in terms of diversity. So some of the highest percentages being paleoceanography, so this study of ancient oceans, around about 38%, and marine biology only being at 12.5%. So pretty abysmal that only 1 in 10 faculty members in this subject are female identifying. But a recent survey did come out and say that around about 48% of gamers identify as female. So there's clearly a massive disconnect with the number of people being engaged through games and the number of people being inspired, the number of female identifiers being inspired to continue academia to the point of faculty within the earth sciences. But gaming isn't perfect. Within the US, 72% of gamers identify as white. So there's a huge ethnicity issue in terms of gaming. Obviously, there's probably some socioeconomic factors in there, but it's very white dominated. But at the same time, it's still significantly better than what the earth sciences are doing in terms of doctoral degrees. So even though games aren't perfect at this 72%, doctoral degrees, 90% of which are going to white people. So there's obviously a problem in earth sciences, which has been recognized many, many times. And I'm not saying that video games are by no means going to fix the issue, but it's at least a different, refreshing way to engage audiences that are currently being essentially excluded from earth sciences. So generally, there are 4 ways in which people can learn through video games. The first one is game mechanics to teach specific skills. And the most obvious one of these is that map reading. The majority of modern day video games see players moving around these 3D landscapes where ultimately they're given a map. They need to orienteer themselves, a lot of which many of you probably did in like primary school or high school, in terms of being able to orientate yourself on a map and be able to just find out where you are. The second one is expanding vocabulary. A really good example of this is Pokemon, literally from the variety of moves that a Pokemon can use. So an earth sciences related one is the move Fissure. Obviously, the opening up of these cracks in the ground that ultimately one hit knock out your opponent. But for a 7 or 8 year old who's playing Pokemon, the word Fissure just isn't something that anybody would come up with. So it is kind of expanding the repertoire of words that a child can use. The third one is improving social skills, and to be honest, not until relatively recently did Pokemon become an actual multiplayer game, like a truly multiplayer game. But just by me presenting here with public speaking skills, as well as people like kids in the playground talking about and trying to communicate what they did and describe what they did in the game the following day. And then the fourth one is this tangential learning, which is almost a way of saying accidentally learning. So a learning alongside playing and enjoying the game. So you could be enjoying a game such as the Assassin's Creed game, where you're in a historical setting, let's say ancient Greece, and you are learning about ancient Greece, ancient Greek historical events at the same time as playing the game. So you're learning almost in tandem. So Pokemon specifically, all the Pokemon in the games, as well as the regions of the games, are all based on some kind of real world context. So the locations themselves, the first 4 series or generations of games are all based on different regions of Japan. And then we move into the more later games where they're based on Europe, such as Northern France and the UK, as well as North America with the New York State, as well as Hawaii. And then last year, obviously, some of you are uh, probably know that Paldea, this Pokemonified Iberian Peninsula of Spain and Portugal. And hopefully, if you're familiar with Spain or Portugal, you might recognize some things straight away, like these northern Cantabrian Spanish mountains, as well as the positioning of Barcelona on the east coast, as well as Madrid in central Spain. Obviously, artistic license was taken with the crater in the middle, but for the most part, everything's there that you would imagine being there. But there was one thing that me and Ed really did think about in terms of trying to use games as an educational resource. And it's basically that we wanted to try and find one game that could teach a series of different topics, as opposed to saying to schools and teachers, okay, you need to go out and not just buy a console, which is expensive, but you also need to buy 20 games to learn 10 different things. So we were really trying to find one game that encompassed quite a lot of different topics, and we settled on Pokemon Legends Arceus or Arceus, depending on who you are. Um, so this is kind of what I'm going to kind of summarize in terms of the little things that you can learn from the game. So the first one is map reading skills. On the top is the illustrated version of the map from the game, this kind of rectangular shape island, as well as on the bottom left, you have the island of Hokkaido, northern Japan. And you see there's instantaneous like similarities in terms of the shape. Some really strong geological structures in there as well, like this north-south trending mountain chain in both areas, numbered 6. And you also get these small lakes in each corner of the island with these small islands within them that are also mimicked within the game. And then just for context, for any geologists out there, I don't think there's many of them, at the bottom right, there's a geological map of Hokkaido as well. But there is a lot of smaller, I guess, is the way to like more niche types of things that you can learn in terms of earth sciences from the game. So you can learn about historical geology. You can compare obsidian, this special volcanic mineral that's generally formed from the release of this from lava that is very, very rapidly cooled, leaving this crystalline structure that is glass-like. And then also comparing it to black augurite, which is this fictional mineral in the game, which is heavily associated with this Pokemon called Cleavor on the right. And Cleavor has these black axe-like things attached to its arm. And when you go onto Pokemon's website and you read a little bit more about the Pokemon, you see that there's special minerals found that ultimately form and allow this Pokemon to evolve. And when two of these Pokemon fight each other, chips start coming away, and the fragments are actually used by people on the island as crafting tools. And when we look at the historical context of Hokkaido, we actually find that obsidian, which is kind of like mimicking this black augurite, was used by early settlers on the island of Hokkaido as a crafting tool. So it's the complete embodiment of a literal mineral into a Pokemon with context surrounding it. Hopefully some of you did a little bit of physical geography while you were in high school, and you get some really nice coastal features in there. So you get a really nice sea cave with progressive erosion, leading to sea arches, and then these very dramatic sea arches in the game. And then you can compare that to the island of Hokkaido, and you also see these really nice sea arches and sea caves in the real world. And even though it's still a virtual game, obviously a virtual experience, these kind of features of coastal erosion are literally textbook. They are perfect, like perfectly shown, perfectly demonstrated, which is something to experience in the real world. You would have to go to very, very distant locations, which would cost a lot of money. We also have some very classical geology in the game. We have some volcanology with this island called Firespit Island, which is this volcano, which had a very, very large eruption in the past, much like Mount St. Helens with this little GIF on the right-hand side. With the eruption being so explosive, it literally blew the top of the volcano off to the point where you have this caldera. And then the continued lava flow within the volcano ultimately built up, creating a new active vent. And then just for illustration purposes, we added on where the old summit would probably be if we just navigate where the slopes of the volcano are. But as I mentioned, there are a few lakes on Hokkaido and in the game that have these small islands within, and these are exactly the same as that volcano that I just described. So you have this very large volcano, which was so explosive it blew the top off, leaving this very crater-like structure with a plug on the inside of it, which ultimately just flooded, leaving a lake with a small island within it. And what you can do is compare the game on the left-hand side to the real-world Hokkaido on the right-hand side, and they're literally mirror image. So it's literally, if you wanted to do the geology of Hokkaido, for example, rather than spending thousands and thousands of pounds traveling to Hokkaido, you could literally just give them the game and give them some geological context, and then they could run away with it. But then in terms of Pokemon, there's a lot more to them than just the games. There is the TV show, which hopefully some of you might be familiar with, this kind of snapshot of who's that Pokemon. And some of you might be able to instantly go, oh, it's Kabuto, which is inspired by a trilobite, one of these ancient crustacean-like creatures millions and millions of years ago. And the idea being that if your favorite Pokemon, for example, was Kabuto, you would ultimately be possibly inclined to go away and try and learn more about its inspiration. And then this kind of continues on. Some of the other possible Pokemon, who hopefully some of you might be able to guess, is Omanyte. And it doesn't take a genius to jump from Omanyte to Ammonite, literally being, again, the literal representation of one of these fossil creatures. And this is really, really common within the Pokemon games, with the actual Pokemon being inspired by real world and fossil and modern animals. There are a few educational problems with Pokemon, evolution being one of them. Obviously, evolution isn't instantaneous. It's not stepwise. It's very progressive and slow. So this addition of a horn or gaining of a wings isn't something that would be instantaneous. But that doesn't stop people from trying to understand it. So some people online have tried to create phylogenetic or trees of life linkages between humans as well as some of the primate style Pokemon in the game. And then people have done this on the scale that literally includes every single Pokemon that has ever existed. But then the last thing really with Pokemon and Earth Sciences is that it's not just rocks, as hopefully you've kind of got that impression. It's also climate change and understanding the world that we currently live in. And Pokemon in more recent years, more specifically Pokemon Sword and Shield, which is set in a fictional United Kingdom, as you can see, like Big Ben in the background there, kind of acknowledges that the Industrial Revolution happened and climate change is happening. So this Pokemon on the left-hand side, this gentleman with a pair of top hats, is a Weezing, if you're not familiar, and literally in its description in the game, it consumes industrial smog and then emits clean air. So it's literally direct response, evolutionary response to climate change. And then in the bottom right here, you have this Pokemon called Corsola, this little pink coral reef almost, that was introduced in the late 1990s as a very happy Pokemon living in tropical seas. that ultimately in Pokemon Sword and Shield died. It literally became a ghost. And its Pokedex entry describes it as due to climate change, increasing temperature, acidification of the oceans, this Pokemon has been driven to essentially extinction. So that's basically the take home, really, in that Pokemon can be used for more than just gaming. Hopefully everybody here kind of agrees with that. And that we can almost create perfect curated experiences from these games as opposed to just reading a traditional textbook. And then a tiny little plug at the end is that on Twitter, Ed runs a Twitter competition to try and find the best Earth science related Pokemon with the Geomon Cup. So if you go ahead and follow them, you can have a vote and see what comes out on top. Thank you.